So, very good evening to one and all. Thank you for your presence in our 30-day masterclass on advanced VLSI design and verification. So, very good evening for early comers. So, very good evening Bharatra Singh, Sri Satya, Vaishnavi PV, Sampath. Very good evening. Thank you for your presence in our this session. So, today is 19th day. Today we are gonna see I2C protocol, I2C communication protocol, integrated circuit protocol. So this is an important protocol while interfacing the external peripheral with the controller with the chip. Okay, so we'll see the spec of this protocol and also we'll see constraint. So we last class we missed to see the some constraints. So this we'll see this firstly. We'll see this firstly sample code for sequence making while using constraint. So and then we will see the I2C protocol specification. So what are the I/O signals and also what are the main input and output signals, and then what are the functionalities of I2C, what are the speed of I2C. So we'll see in the one by one classes. So very good evening Naranamurthy, thank you for your presence. Okay, so let's wait for a few minutes. There are less members in the live, so let's wait for a few minutes and then we will start the class. So is my voice is clear? Can anyone respond in chat box? I'm audible to you. Is my voice is clear? Can anyone respond in chat box? Okay. So jet put S in chat box. If my voice is clear means just put S in chat box. Okay, thank you for your response, Vamsi Krishna. Yes, so I think we can start now. So firstly we will see the constraint code. Okay, so this is a code for that constraint to give the output of like 0 1 0 2 0 3 0 4 0 5 kind of sequence. So they if some interviews you may receive kind of these questions, just write the code to print this sequence of output. So by using constraint you can easily make that. So while doing randomization, so this is a constraint. So last class we see the constraint. So you can see here this is my constraint inside my module class. Firstly I'm creating the constraint inside my class name is A. This is my dynamic array. Okay, so and then this is my two constraints. These are my two constraints to get this same sequence output. Firstly, I am setting the array size. So I'm setting the array size of a dynamic array is 10. So this is a size method. So by using this, you can set the array size. So I'm setting the array size equal to 10. It means it having 10 memory locations in dynamic array. So and then I'm checking so you can easily understand this sequence. Okay, just a minute. So here in the even position, so in the even position only they are filling the numbers like a 1 2 3 4 5 sequence of numbers. In the odd position, 0 is my first index, 1 is my second index, 2 is my third index. So in the even, so 0 1 2 3 4 5 6 7 8. So in the eventh index, so this is a even index, this is a even index, this is a even index, this is even index, even number of index. In the even number of index they are storing 0, and the odd number they are giving the inputs like that. They are adding the values of sequence like a 1 2 3 4 5. Okay, in the even index they are filling with 0. In the odd index they are giving values with the sequence number 1 2 3 4 5 kind of thing. So okay, so to find whether that particular index even or not, even or odd, means you can use this model operator. if the I model of 2, so if you take like I equal to I model of 2, it means remainder of 2 by 2, so 2 divided by 2 means you will get the remainder 0. If the remainder is 0 means that number is even number. If the remainder is having the 1 means that number is odd number. So by using that logic I am making that, so I can get the data whether the index is even or odd. If the even means I am storing 0 over here. If the odd means I am storing this kind of calculations, I plus 1 by 2, it means I'm storing 1 2 3 4 5 sequence. Okay, in the first odd index 1, second odd index 2, third odd index 3, fourth odd index 4 5, like that I am storing the values. To detect that I using this logic, I plus 1 by 2. So if you give the some value for I means you will get some index. For example, 3 is the odd index. Okay, 3 is the odd number, this is the odd index. So I equal 3 means 3 plus 1 4 by 2. So 4 by 2 means 3 plus 1 4 by 2 2. So in the third index I am storing the, so in the third index I am storing 2. So third index nothing but 0 1 2 3. This is the third index I am storing 2. So this is how I am storing the sequence of numbers. Okay, so this is a formula for that. And then in the initial begin I'm creating the I'm allocating memory, I'm randomizing, I'm printing the array. Okay, so and then just save and run. So you can see here my output is 0 1 0 2 0 3 0 4 0 5. So this is how you can use the constraint. And then this is how the interviewer will ask the question to make this kind of sequence of outputs. They will ask 5 5 5 4 4 4, just they will ask print like 5 4 5 4 5 4 or any other thing. So they will ask these kind of logical questions by using the constraint. Okay, so this is how I'm trying to conveying to you. So constraint you can use, by using the constraint you can limit the randomization, and then you can do your logic by using the constraint also. Okay, while writing the SystemVerilog code. So coming to the project of I2C, integrated circuit, it is a off-chip protocol. It is a serial communication. It is a multi-master, multi-slave communication. So and then it is a high-speed protocol also. Compared to UART, I2C is more speed. Okay. So in this session we are gonna this protocol spec only. Okay, firstly I2C, integrated circuit. It is used for off-chip communication. So you can communicate, you can connect the external peripheral with the chip. Okay, by using this you can communicate that. So and then these are the contents we are going to see. Introduction, I2C fundamental, physical layer, speed, timing specification, addressing mode, data transfer, advanced features, protocol comparison, application and examples. So there are a lot of things we are going to see. So firstly, introduction. So what is I2C? So integrated circuit communication protocol. It is a two-wire protocol, two-wire serial communication protocol. Okay, the main thing is serial communication protocol. So two-wire is nothing but it having only two wires, like a STA, SCL. So STA, the SCA one wire, STA one wire, SCL is another wire. In the STA wire, we can send the data based on the clock pulses. So where we give the clock pulses means we can give the clock pulses in the SCL clock, serial clock wire. Okay, we having two wires. One is STA, another one is SCL. Okay, so and then this is a multi-master, multi-slave. It means you may have the multiple masters, so multiple controllers, multiple slaves, like a printer, monitor, memory or RAM, ROM. So you can make communication between the multi-master, multi-slave, but at a time you can only do with only one master and one slave. Okay, so it is a synchronous. Why it is synchronous means it is fully based on the clock pulses only. It is working. So for compared to the UART is asynchronous. Why? Because of it is independent of clock. But in the I2C it is dependent of the clock pulses. So we can call this like a synchronous. Okay, and then off duplex communication. So off duplex means either you can send and receive at a time. You can't both do at a time. Okay, this is the off duplex communication. So and then these are key features, simply two wires. So two wires means you can reduce the hardware size, and then you can reduce the hardware need. Okay, by using this 2 wire you can reduce that. So and then address each I already said no, it will work with multiple master, multiple slave, so each and every slave having a specific unique address. Okay, by using that you can communicate with master will communicate with slave. Okay, so and then advantages. So these are the advantages, like a minimal pin count, and then no need for chip select signal, and then multi-master capabilities, built-in collision detection, wide industry adoption. Okay, these are the main advantage of the I2C communication. So and then I2C fundamentals. So basically it having the two wires, like a serial data, serial clock. So it is a bidirectional. So it will, from that one wire only, master will send the data to slave, slave will send the data to master. So this is a bidirectional wire. So and then master slave architecture. So firstly the master only one who start the who initiates the process, only master will send the start condition. So it having some like UART also. So you know the UART means it having some start bit, start bit, stop bit. Same like here also it having the start condition, stop condition, address, acknowledgement, non-acknowledgement, and then data bits. So it having the same syntax. It means same logic. Start condition, stop condition, address. So firstly master will initiates the communication. So master only will start the communication. Okay, and then slave will respond, and then it receives the clock. So and then multi-master. So multi-master we can also use in the I2C. So under addressing we know that each slave have the unique address. So and then open drain configuration. It means both SDA SA lines are open drain output. It means they are actively high. So by using the pull-up resistor, that lines having the always high value. So if you want to for example, assume like a multiple master, multiple slave you having. So it means master 2 have to communicate with the slave 3. It means the master will catch the must have to catch the I2C bus. So it is known as I2C bus. STA SCL is known as I2C bus. Master 2 must have to come catch the firstly bus, then only the master 2 will communicate with the slave. So to catch the bus means there's a process that is called as arbitration. It means if you are having the one master one slave means there is no need for arbitration. But if you are having the multiple master, but you are having only two wires, STA SL, so multiple master means all masters are always looking for the bus, then only the master will communicate with the slave. But so if the all master are sending data parallelly means there will be collision will happen. So this is a disaster. So to neglect that disaster, you can there is a process like arbitration. So it is like arbitration is a process of giving the bus to respective master. So arbitration is nothing but kind of phrase. So we know that I2C lines are actively high. Why? Because of they are used pull up by using the pull up register. The I2C, SCL, STA and SCL line are always active high. So if you give the input for if you give the in 0 for that lines like STA lines means the master will get the bus. It means so there are 4 masters. The second master must need the bus access. So while doing the arbitration, the second master will give the second master pull down the I2C lines. So it means give the 0 for that I2C lines like I2C bus. Then only it will the second master will get the access to get the bus. Okay, it means the second master firstly pull down the lines, then only it will get the bus. If another master pull down the lines means that particular master will get the I2C bus. So firstly there is a race between the masters. So one who pull up their I2C lines means that master will get the access. Okay, the main thing is we have to give that particular master have to give 0 for the I2C lines, then only it will get the bus. So okay, so why? Because of the I2C lines are actively high, so always it having high value. So if you pull down the I2C lines, I2C bus means the master will get the access. The main thing is there is a race between the masters who will firstly pull down the I2C buses. If the second master will pull down the I2C lines means that master will get the access. Okay, this is how it works. This is how it works of arbitration. Okay, so and then it is half 2 plus communication, we know that. So and then physical layer. So physical layer is nothing but there are two physical layers, only ST and SCL. So these kind of resistor, pull-up resistor, these are comes under the power electronics. So there is a speed. So speed is also, there are 4 types of speed in the I2C bus. I will show you one by one. So there is a speed modes: standard mode, fast mode plus high speed mode, and then ultra fast mode. So in the standard mode you can make speed like 100 kilobits. In the fast mode 400 kilobits, 1 megabits in the fast mode plus, and then 3.4 megabits in the high speed mode, and then 5 megabits in the ultra speed mode. So this all the speed depends on the capacitance of a pull-up resistor and also setup time, hold time kind of thing. Okay, so this is the application of the I2C buses based on the speed. So fast mode is mostly used for high speed peripherals. So and then high speed mode for flash memories. So and then ultra fast mode for wide write only operation like EEPROM kind of thing. Okay, so this is the speed of the modes, I2C speed modes. So and then timing specification, setup time, hold time. So we already know the each and if that this is the I2C is synchronous, so it is using the clock for data transferring. So it having the setup time, hold time. So the data must be stable in the setup time and also in the hold time. Then only you will get the correct data. The I2C master will send the data to slow will correctly. Okay, the data must be stable in the setup time and also hold time. So and then rise and fall times. So signal transition speed and then clock period. So minimum time for complete one cycle. Okay, this is the definition for the timing specification in the I2C. So main thing is you have to understand the frame format. Okay, frame format is very simple only. So I will just show you the picture. Okay, you can see now. So in the UART we have in the start bit 8 data bit and then 1 stop bit. So same here. I think it's not clear for you. Yeah, so this is a frame format of I2C. Firstly, it having some start condition, 7 to 7 or 8 10 bits of address. This is address for slave. Okay, slave address, and then read and write bit. It means if the reads in this particular bit is high means you can read from the slave, or low means you can write to the slave. Okay, and then acknowledgement or non-acknowledgement. This is one bit. So this is a reference, this is a feedback bit, like it is a response from the slave. So for example, firstly I will tell the frame format. So 8 data bit and then acknowledgement, 8 data bit, acknowledgement, and then stop bit. Okay, so start bit, address bits, and then write and write bit, acknowledgement bit, 8 bit of data. This is a raw 8 bit of data, and then another acknowledgement, another acknowledgement, and then stop bit. So you can, if you want to send 5 bit of data means 5 byte of data means you can increment like this: 8 bit acknowledgement, 8 bit acknowledgement, but it will only send 8 bit at a time. Okay, it will send only 8 bit kind of thing, 8 bit of packet only. So first is start condition. So there is a logic for start condition. I will tell you another upcoming slides. Main thing is it having start condition, address for slave, and then read or write bit, and then acknowledgement. So this acknowledgement is nothing but response signal from slave. So slave to master. So slave is telling to master like I am ready. So I can I can get the data as what you are telling. So it means firstly master will start the process, and then master will send the address for the slave. If the slave address and the master address are matching, means so the particular slave telling to master, okay, I am ready, address is matching, so you can send the data. Like that slave is telling to master by using this acknowledgement bit. And then after receives the acknowledgement bit to the from the master will send the data of 8 bit of data. So and then every 8 bit of data, the slave responds to master, okay, I got the 8 bit of data, this is my acknowledgement, you can send another 8 bit of data to me. So like that it will communicate with the master. So each and every 8 bit of data, there is an acknowledgement from the slave side. So I received the data of 8 bits, so you can send the another data. By using this acknowledgement bit, it can share the information to master. Okay, so and then if you want to send multiple bit, means you can use like this: firstly 8 bit acknowledgement, and then next 8 bit acknowledgement from slave, and then next 8 bit, and then acknowledgement from slave. If there is any happening, if is there any data loss between the 8, so for assume like the slave receives only 5 bit of data instead of 8 bit, it is receiving only 5 bit. So the slave must have to tell the error signal to master. How it can say means, they will the acknowledgement they will send the non-acknowledgement. So you can see here NAACK, it is known as non-acknowledgement bit. So it will pull either bit. Okay, if the low means there is no error. If the slave sending the 0 bit for the acknowledgement means no error. If it is bit having the 1, it means there is an error in the data which is received, which I received from you. So this is how the slave will telling the response to master. Okay, so and then this is how, and then after completion of all the bit, so master will send the stop condition. Okay, it's not like a stop bit, it is a stop condition. I will tell you what is a condition. Okay, this is how the frame format will look like. Okay, so and then this time for, if you guys are really interested in this masterclass, you can convert this masterclass into 1 month of internship program. In this internship program, you will get the recorded sessions, PPTs, project, and then internship academic report, and then you will get the confirmation letter from ITE, and then finally end of the 1 month of internship program, you will get the internship certificate from IETE. So and then these are the benefits you will get, and then these benefits all you get from just 999, discounted fee of just 999. So our regular fee is 499. So you can convert this masterclass into 1 month of the internship program. So you can also use the link in chat box. You will get the registration link for internship. You can use the link in chat box. So and then register yourself. So this is the process of getting internship program. So and then coming to the class. So this is a frame format of I2C. So start bit and start condition, address, read or write, and then acknowledgement from slave. Data will send the data, master will send the 8 bit of data, and then acknowledgement from the slave, data, so acknowledgement, and then another data, another acknowledgement. After completing the process, the master will send the stop condition. Okay, so let's see what is the start condition and what is the stop condition. Okay, so stop condition and the start condition. So just a minute, it is not clear for you. Yeah, this is clear for. So this is a start and stop condition of I2C. While SCL is in a clock line, it is always toggling, it will give only clock pulses. So while clock is high, so the level of the clock is high on that time, the STA is a data line. If it is changes from high to low, okay, if it is changes from high to low, you can see here high to low. if it is changes from high to low while the clock is high, so this is known as a start condition. Same like in the while the clock is high, if the STL line changes from 0 to high, low to high, it is known as stop condition. Okay, so this kind of transition we made by the counters in the code. Tomorrow we'll see the I2C code. So this is the main condition. Stop condition means low to high. So stop means it will change from low to high. STA will change from 0 to 1 while the clock, like a clock line and the high level. Okay, so same thing. So if the changes the high to low, 1 to 0 while the clock is high, means it is known as start condition. Okay, I think it's clear for you. So this is a start and the stop condition of I2C. Okay, so and then let's see the frame. We already seen the frame format. So this is addressing mode. So timing specification already we see. Address mode, 7-bit or 10-bit of address. You can see here, this is a 7-bit address, this is a 10-bit of address. So and then reverse reserved address, 00 for general call, and then start byte, and then reserved, and then 10-bit of addressing. So and then data. So this is a start condition while clock is high. If it changes from high to low, it is known as start condition. If it changes from low to high, it is known as stop condition. So and then data frame format, start condition, 7-bit of address, read or write bit, acknowledgement bit, 8-bit of data, acknowledgement bit, and then stop condition. Okay, so and then acknowledgement if is 0, data it means successful. So if it is acknowledgement is 0 means if the acknowledgement from the slave to master, if it is 0 means there is no error, so you can proceed with another data. So if acknowledgement, so a NAC bit having 1, so it means this bit having 1 means there is an error in the communication. Okay, so and then master, it means you can see here master acknowledgement to continue, NAC is to end the read. Okay, so and then slave acknowledgement is if it is end the acknowledgement means okay, I'm ready. So NAC means busy means there is an error, the slave needs some time. So this is how we can make the communication between the acknowledgement means we can send the next data. Non-acknowledgement means there is an error, so or else slave in the busy state. Okay, so and then advanced features, clock stretching. So clock stretching is nothing but allows slave devices to slow down the communication when they need more time to process data. So assume like a slave master sending the data to slave, but slave needs some time. Why it needs some time means the slave's device have to spend time to process of like a to do the processing of data, so it needs some time. So on that time the slave uses the acknowledgement bit, so it means it will give the high, so it will give the high value in the acknowledgement bit, means it is known as non-acknowledgement to the master. So master will understand that, so there is an error, or else the slave needs some time. So after the acknowledgement bit only, the slave after acknowledgement bit from slave only, the master will send the data. So always master will looking for acknowledgement bit, acknowledgement 0 from the slave. If the slave have giving one like a non-acknowledgement signal, means the master must have to wait. So this is a clock stretching. So on that time the slave will get the more time to process the data. Okay, the slave holds a SCL clock line low to pass the communication. So by using the non-acknowledgement bit, the slave will pull down the SCL line low. So why? Because of the slave need the time. So and also slave need have to slow down the process. So it will just pull down the SCL line. Okay. So and then master response. So master waits until the SCL goes high. So it is use cases like slow EPROMs and then busy microcontrollers. These are the use case of these kind of scenarios. Okay, so and then this is the process of clock stitching, and then this is a process of bus arbitration. So nothing but stimulus start, bit by bit collision detection, graceful breakups. So this is how bus arbitration is working. So I already said no. One who would send the one who pull down the I2C bus means that particular master will get the access to send the data to slave. Okay. So error handling. So NAC means non-acknowledgement response, bus timeout. Okay, clock stretching, too long, missing sub condition, auto failure. This all comes under the bus timeout. So address not recognized slave BC or not ready slave. It is comes under the non-acknowledgement response. So and then this is how comparison between the I2C SPA UART. So I2C is a two line. SPA needs 4 wires. UART requires only 2 wires. There is a main thing is speed. So compared to the I2C, SPA is a more speed. Okay. So arbitration. So arbitration is nothing but I2C lines SCL, STA are always high. Why? Because of they are using pull-up register. So that particular lines, like particular wire, having the high value only. So if you are dealing with multiple masters means if you the particular master want to catch the bus, want to get the bus means that particular that particular master firstly have to pull down the wire. So pull down the bus, pull down the STA wire, then only it will get the bus. So there is a competition between the competition among the masters. So which master will firstly pull down the wire, pull down the bus means that master will get the data. So not get data, we get the access to control the I2C bus. Okay, this is how arbitration is working. So and then there is a difference between the I2C buses like I2C, SPA, UART protocol communications. Main thing is SPA is faster than I2C. Why? Because of it is a it is using the 4 wires like MOC, MISO, chip select, and then UART is we know that UART is very slower than I2C and SPA. Okay. So the main thing is there is no error, there is no errors conditions in the SPA, but in the I2C we having the acknowledgement bit. Okay, by using that we can get the error conditions. So and then applications of the I2C. So application means temperature sensor, memory devices, real-time clocks, analog to digital converter, IO expandables. Clock stretching. So clock stretching means so master will doing the process very fastly. Master will send the data very fastly. Okay. So but slave device are not capable to receive the data at the same speed of master. So on that time the slave pull down the clock line. Okay, pull down means low. So low. Then why it is doing like that means to slow down the process, the slave will pull down the clock to reduce the communication speed. Okay, so I will show you here. So slave holds the SCL line low to pass the communication. Okay, why? Because of the slave device needs some time. Okay, so based on the clock pulse only master will send the data. Based on the clock passage only the master device will send this data. If the clock is low means master can't capable to send the data to slave. Okay, so slave will holds a SCL line like a SCL line like a clock. So it's now literally SCL, the clock will be low. Why? Based on the slave activities, the slave will pull down the clock line like a low for some time to slow down the communication. Okay, so this is how the clock stretching is working. So I think it's clear for you. So Kanam. So I think it's clear for you. I can proceed with Main thing is class stretching is nothing but to the master needs some time to process, so that the slave slow down the process by using the clock, making us the clock low for some time. If there is no passage, means the master won't send the data. Why? Because of it is based on the passage only, based on the clock passage only. The master will send the data will send the data to slave. Okay, from the one passage it will send the one bit. In the next passage, the master will send the next passage. If it is no passage, means master won't send the data to slave. Okay. So and then implementations. This all comes under the calculation while dealing with code. You can easily understand. So and then this is fully based on the physical part of the communication, physical part of the wire. So and then implementation, PCB layout, so we won't need that. And then power supply, so place, bypass, capacitance, need each other. This all comes under the PCB kind of thing. So main thing is protocol implementation, write basic. So acknowledge, wait for acknowledgement from slave, send the data byte, wait for acknowledgement from the after each byte, send the stop condition. So this is a basic write sequence. Start condition, send device address with the write bit, and then acknowledgement from the slave, send the next data to slave, and then wait for acknowledgement from the slave, and then stop condition. So and then this is a read bit, like if the read bit, here I am using the write bit. If it is write bit, the same, this is only one bit. If it is having 0, that particular bit having 0 means you can read from the data. If it is having 1, read and write bit are 1 means you can write into slave. Okay, this is how we can make the communication between them. So and then we will see the code tomorrow session. So this is a conclusion to summary. So ITC is a versatile two-way communication protocol. Multiple speed modes, proper timing, and the electrical design are critical. So and then 7-bit addressing covers most of use cases. So 7-bit means 2 power 7, I think 254. So kind of thing. So you can 254 addresses you can make. So and then built-in arbitration enables multi-master system. And then best practices means design, calculate the pull-up register. So if you want to write that code, means you can also calculate the pull-up register value. And then layout, software test and testing, debug. So for debug means you can use the logic synthesizer or analyzer. So and then implementation checklist, pull-up register properly sized, bus capacitance with the limits. So these things comes under the electrical part, circuit part. So main thing is we have to give the correct address for the slave. Okay, so and then this is a full spec of the I2C. Main thing is clock switching and then clock arbitration, and then start condition, stop condition, addressing modes, and then addressing, and then read and write bit, acknowledgement from the slave, and then 8-bit of data. So you can send only 8-bit of data. So in one passage you can send 8-bit of data. Sorry, you can send only 1 bit. Okay, but it is a serial communication. So I think it's clear for you, Dr. Rugaya Kanam. So if you have any doubt, means you can ask now regarding this I2C spec. So clock stitching. So this is how you can see the clock stitching. You can see here the slave device pull down the SCL line to low. So you can see here low only, so low value here, and the time master cannot send the data to slave. because of there is no passage, so master cannot send the device to slave, so clock being stretched by the slave. Okay, this is how clock stretching is working. So and then this is for today, guys. We'll see the code tomorrow, code implementation tomorrow. The main thing is arbitration, clock stretching, start condition, stop condition, address, acknowledgement, and the read and write bit. So this is a main important thing you have to know. So and then thank you, guys, thank you for listening. We'll see tomorrow with the code of I2C. I think it's clear for you. So thank you, guys, thank you for listening.